All right, another property we're going to learn is called the distributive property. Um, the distributive property essentially says, if we look up here, that if you have numbers a, actually, let's just use this. So, for example, this says 8 times 10 plus 4. That could be rewritten in what's called kind of distributing in here. 8 times 10 plus 8 times 4. So it's a different way to write the same thing. Either way, you'd end up with the same numbers. So you could either do 8 times 14, or you could do 8 times 10 plus 8 times 4. Either way, you'd get the same answer. You can do the same thing with subtraction. So notice we have 4 minus 2 in parentheses. You could rewrite that as 3 times 4 minus 3 times 2. Might be beneficial, sometimes easier to solve there. So if you buy 4 $11 CDs and 4 $14 CDs, we could write that essentially in this way. We could, and let's write it in two different ways. So if we wrote 4 times $11 for the 1 CDs, and then we need to add that 4 times the $14 CDs. So we could do that, and we would get 44, right? 4 times 11. My pen will work here. Here we go. 44 plus 4 times 14 is 16. 56. And you would get 100 bucks. You could also write that as 4 times 11 plus 14, and then you just have 4 times 25. A little bit easier to do in that case. So depending on the scenario, sometimes one part of the distributive property might be easier than the next. So I want us to write an equivalent expression. So what we're doing here, and I even kind of like to draw the arrows in, is we are distributing or kind of passing out the number on the outside times everything on the inside. That's what this distributive property means. Take the number on the outside, multiply it by everything on the inside. So let's do this. So we have negative 3 times 6 plus negative 3 times 4. Don't forget to bring that negative sign there. So that's a different way to write it. Either way, we're going to get the same answer. So we're going to end up with negative 18 plus a negative 12. That's going to give us negative 30. Signs are the same. We add them up. So we're just kind of practicing here. So again, take the number on the outside, multiply it by everything on the inside. 12 times 18. This time we have a minus sign, so it's going to be a minus in the middle, times 12 times 11. Okay. Use distributive property to write, and actually we're not even going to solve some of these. Just want to kind of rewrite them in the other form. There's two forms. There's this form and there's that form. So here now we're going to work backwards. What's happening here is if we're going to take a common number out. If we can take a common number out, then we're just left with kind of what's remaining. So if we can take that number out, then we're just kind of pretend those aren't there, take them out, we're just left with 13 minus 3. Okay, so if we can undistribute, kind of work backwards, we want to always get things into kind of this form, potentially. All right, and so we're left with 13 minus 3, and then whatever, and then the common number you distribute out always goes on the outside. Okay, so that's the other way to write that. Okay, so this could help you here. So you buy 12 party favors costing $1.99 each. So you could just do $1.99 times 12, or you could use the distributive property. Kind of make things into easier numbers. So what you could do instead is what you could say is, well, what are easier numbers to work with? You could instead multiply 12. You can follow me here if I can get my pen to ever work again. we could say that $1.99 is the same thing as $2 minus 1 cent. Now we have a little bit easier number to work with. Now we have 12 times 2, right? We're distributing in, minus 12 times 1 cent. So 12 times 2 is going to give me 24. 12 times 1 cent is going to give me 12 cents. And so I'm left with $23.88. So that was a little bit easier numbers to work with there. Okay. So same scenario here. So when it's in this form, you want to undistribute. Take out that common number, and again, we're looking for something in this form here. Okay, take out that common number. That's what goes on the outside. Whatever is left is what we fill in the middle here. So now we have 3 times 7. We get 21. Kind of, in my mind, makes it a little bit quicker here. Now, some of these wouldn't always make sense, but again, let's practice distributing. 8 times 12 minus 8 times 5. So now we have 80 times, so we have 8 times 12 is 80, 1696 minus 40. So we get 56 there for our answer. I'm going to skip some of these, go down here and do it. A couple other problems here where you might use the distributive property kind of to make things easier sometimes. So if you had, let's say, for example, 11 times 5/8 plus 11 times 3/8. Again, we could take those common numbers out, take them out, and now all we're left with is 11 5/8 plus 3/8, and that's going to equal 11 times 8 over 8. Anything over 1, or anything over itself, equals 1. And 11 times 1 is an easy number to do, rather than having to do all that math in between. Another time you could use it is if you are just trying to make a problem a little easier. You could split up something. So if you had 8 times 8.2, 7 times 8.2, that's kind of a tricky number to work with. So instead, what we could say is, well, 8.2 is really just 8 plus 0.2. And then I could distribute from there and have a little bit easier numbers to work with, kind of do it separately and then add them back together. So then I could say, oh, that's 56 plus, oh, let's actually do the work, I'm sorry. Frozen screen here. Apologize. So 7 times 8 plus 7 times 0.2, so we get 56. Whoops. Plus 7 times 2 is 14, but we have 1 decimal place, so it's 1.4. So pretty easy numbers to work with. So we're going to have 57.4. Okay.